Hello viewers, welcome to my channel Online Biology Tutorials. In today's live, we will be reading Chapter 1, Chemical Reactions and Equations of Class 10th NCERT. So this NCERT is being followed in CBSE board. However, I have already recorded a playlist of it earlier, but due to background music, I was getting requests that I need to re-record it. I hope the screen is clear. In case you are interested in hearing the audio with some background music, you can come to the playlist of my channel and there you will be able to find Audiobook Class 10 Science. Requesting everybody that whenever you'll be hearing the audio of this chapter, please do share it with your friends for the maximum reach. Let's begin with the reading of Chapter 1, Chemical Reactions and Equations. Class 10 Science, taken from NCERT, that is being followed in CBSE. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers. An iron tawa, pan, nail is left exposed to humid atmosphere. Grapes get fermented, food is cooked, food gets digested in our body, we respire. In all of the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Activity 1.1. Caution: this activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3 to 4 centimeter long by rubbing it with sandpaper. Hold it with a pair of tongs, burn it using a spirit lamp or burner, and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? Figure 1.1. Burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Moving to the next page. I hope the screen is visible. You may have observed that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Activity 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? Activity 1.3. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. Figure 1.2 is showing you this. Caution: handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observation helps to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of a gas, change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representations in this chapter. Now, this 1.1 chemical equations. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen. They are the reactants and the product is magnesium oxide. The substances that undergo chemical change in the reaction, this one, magnesium and oxygen are the reactants. The new substance is magnesium oxide formed during the reaction as a product. A word equation show change of reactants to products through an arrow placed between them. The reactants are written on the left hand side, LHS, with a plus sign between them. Similarly, the products are written on the right hand side, or RHS, with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Next, 1.1.1, writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formula instead of words. A chemical equation represents a chemical reaction. If you recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 will give MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both the sides of the equation. Such a chemical equation is a skeletal chemical equation of a reaction. Equation 1.2 means this one is a skeletal chemical equation for the burning of magnesium in air. Next topic, 1.1.2, balanced chemical equations. Recall the law of conservation of mass that you studied in class 9th. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical reaction. Is the chemical in equation 1.2 means this one balanced? Let us learn about the balancing of a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc sulfuric acid that has to be added, that will give you zinc sulfate plus hydrogen. Welcome viewers to my channel Ritesh Singh and Arhan Sheikh. The above word equation may be represented by the following chemical equation. Zn plus H2SO4 will give you ZnSO4 plus H2. Let us examine the number of atoms of different elements on both the sides of the arrow. So elements are Zn, H, SNO. Their atoms on the LHS side, for zinc it is 1, for hydrogen it is 2, for S it is 1, for O it is 4. And the number of atoms in the product is also the same. As the number of atoms of each element is the same on both the sides of the arrow, thus it is a balanced chemical equation. So that means this equation which is given here 1.3 is a balanced one. Let us try to balance the following chemical equation. Fe plus H2O will give Fe2O4 plus H2. Moving on to the next page. I hope the screen is clear. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Thunder B plays. Welcome to my channel. Dear, actually this is the recording for the audiobook. In case of any doubt, you can message me in the comments of this video. I'll get back to you. So Fe, H2O, Fe2O4 and H2 are being done in the brackets. List the number of atoms of different elements present in the unbalanced equation. 1.5 means they are talking about this one. So elements in the given reaction are Fe means iron, H means hydrogen and O means oxygen. And the number of atoms of these are 1 to 1. So number of atoms in the product side or the RHS is 3 to 4. It is often, this is step number 3, it is often convenient to start balancing with the composed with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms, we are required to follow this. Initially, in H2O, 1 was there, but in products, 4 oxygen were there. So, to balance, you need to multiply this 1 by 4. That is why LHS and RHS will become equal. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not as H2O4 or H2O whole 4. Now the partly balanced equation becomes Fe plus 4H2O is equals to Fe3O4 plus H2. Arav Parashar, good afternoon. Yes, I'm very much there. Arav Parashar, this is the recording for the audiobook. Once you have all the doubts, when this video will be uploaded, you can type your problems in the comment and I will be back with a recorded video, or I'll take a live session on this video to take all the doubts. But this is specifically the audio of chapter 1. Step number 4. Fe and hydrogen atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS. Similarly has been shown here, because in the reactants or LHS, the number of hydrogen atoms are 8, but in the products, there were only 2. So what are we required to do? We need to multiply this 2 with the 4 to get 8 on both the sides. Shubham, hello. Welcome to my channel, Online Biology Tutorials. In case you have any doubt in bio, the life processes chapter has been completely recorded, and the heredity chapter that is not so given good in NCERT, a complete video series is given in the playlist section. You can come, and in case you like it, you can see the whole video as per your convenience. So we are on step number 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. So in reactants, Fe was just 1. In products, it was 3. That is why in LHS, we have multiplied it to 3. So to equalize iron, we take 3 atoms of Fe on the LHS. So it will become, wow, that's a good score, 98.6 in 10th. Very good. So now the equation is 3Fe plus 4H2O, Fe2O4 plus 4H2. Step 6. Finally, to check the correctness of the balance equations, we count atoms of each element on both sides of the equation. So now our equation is 3Fe plus 4H2O, that will give you Fe3O4 plus 4H2. The number of atoms of elements on both sides of equation, this one, are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced equation. 1.9 means this one. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notations G, L, AQ, and S respectively. The word aqueous or AQ is written if the reactant or product is present as a solution in water. Very good. I don't know how to pronounce your name, but that's a great score that you scored 100 in science. So she or he, I am not so sure. Especially the boxes and experiments were read the best by this student. Harsh Gupta, welcome to my channel. So this is a suggestion for everybody. Once you are done with the revision, please do not forget to play the audiobook, because it helps you in revising all the contents well. And whatever words you have left earlier might be the words you will hear well in audio, and they may help you in one way or the other. So we were here. We have already talked about the aqueous one. So the balance equation 1.9 becomes 3FeS for solid, 4H2O G means gaseous, Fe3O2S means solid, plus 4H2 gas. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and below the arrow in the equation. For example, CO2 plus 2H2 both are in gaseous states. In the presence of 340 atmospheres, it is going to yield CH3OH in the liquid form. So the equation of photosynthesis is this, you should definitely learn: 6 CO2 in aqueous form plus 12H2O in liquid form in the presence of sunlight or chlorophyll. C6H12O6 will be formed in the aqueous form, and this is known as glucose, plus 6O2 in the aqueous form plus 6H2O in the liquid form. Using these steps, can you balance equation 1.2 given in the text earlier? So they are asking you to balance. So whenever you are trying to balance a reaction, it is always to be seated with pen and paper. Now let's do the reading of the in-text questions which are visible on this page. Question number 1. Why should a magnesium ribbon be cleaned before burning in air? Question number 2, write the balance equation for the following chemical reactions. 1, hydrogen plus chlorine will give you hydrogen chloride. 2, barium chloride plus aluminium sulfate will give you barium sulfate plus aluminium chloride. 3, sodium plus water will give you sodium hydroxide plus hydrogen. Question number 3, write a balanced chemical equation with state symbols for the following reactions. So one is solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. 2. Sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution and water. Now we have reached to this portion 1.2, types of chemical reactions. It would be great if I could know the students' city from where are they watching this live. We have learned in class 9 that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapter 3 and 4. 1.2.1 Combination reaction. Activity 1.4, take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in figure 1.3. Do you feel any change in temperature? Calcium oxide reacts vigorously with water to produce slaked lime or calcium hydroxide, releasing a large amount of heat. So the equation is CaO, S means solid. This is known as quicklime. This will be reacting with water in the liquid state. It will give slaked lime, that is written as CaOH2, aqueous form plus heat. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants, it is known as combination reaction. Let's flip to the next page. And we are here on this part now. I hope the screen is clear. Do you know a solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls? Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Calcium hydroxide or the aqueous one plus CO2 in gaseous form. So this is calcium hydroxide. This is calcium carbonate, which is formed as the product in the solid form, written as CaCO3 plus H2O in the liquid form. Let us discuss this side. I think now it is clear. Let us discuss some more examples of combination reactions. One, burning of coal. Carbon in solid form plus oxygen in gaseous forms will give you carbon dioxide or CO2 in the gaseous form. Two, formation of water from H2 gaseous form plus O2 in gaseous form. So it will be written as 2H2 in gas plus O2 in gaseous form will give you 2H2O in the liquid form. In simple language, we can say that when two or more substances or elements or compounds combine to form a single product, the reactions are called combination reactions. In activity 1.4, we also observe that a large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Other examples of exothermic reactions are CH4 means methane gaseous form plus 2HO2 in the gaseous form will give you CO2 in gaseous form plus 2H2O in gaseous form. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The simple name of this reaction is respiration, the process of which you will study in chapter 6. So this is the reaction for respiration. Glucose, which is C6H12O6 in aqueous form, will be broken down by the addition of oxygen. So here, 6 molecules of oxygen are being taken in aqueous form, and the products are carbon dioxide, 6 molecules in aqueous form, water in the liquid form, 6 molecules plus energy. The decomposition of vegetable matter to compose is also an example of an exothermic reaction. Identify the type of the reaction taking place in activity 1.1, where heat is given out along with the formation of a single product. Next topic is this one, 1.2.2 decomposition reaction. So first we'll be reading out this activity. Activity 1.5, take about 2 gram ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown in figure 1.4. Observe the color of the crystals after heating. Next one, have you noticed that the green color of the ferrous sulfate crystals has changed? You can also smell the characteristic odor of burning sulfur. So 2FeSO4 in solid form when heated will be getting converted to Fe2O3 solid, which is ferric oxide, and it will also produce SO2 gas, sulfur dioxide gas, and sulfur trioxide gas. In this reaction, you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals FeSO4.7H2O lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide or Fe2O3, sulfur dioxide SO2 or and sulfur trioxide, which is SO3. Ferric oxide is a solid while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and calcium dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called the thermal decomposition. CaCO3 in the solid form, which is limestone, when heated, will be converted to quicklime, which is CaO or calcium oxide in the solid form, plus CO2 in the gaseous form. Another example of a thermal decomposition reaction is given in activity 1.6. Take about 2 gram lead nitrate powder in a boiling tube, hold the boiling tube with a pair of tongs, and heat it over the flame as shown in figure 1.5. What do you observe? Note down the change, if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide. The reaction that takes place is so the reaction is 2PbNO3 whole 2 in solid form, which is lead nitrate. When heated up, it will be producing lead oxide written as PbO. So there are two molecules of it in the solid form. Along with this, nitrogen dioxide in gaseous form, 4 molecules, oxygen in gaseous forms. So this is equation 1.21. Let us perform some more decomposition reactions as given in activities 1.7 and 1.8. Take a plastic mug, activity 1.7, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in figure 1.6. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Hi, Seema. Welcome to my channel. Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by bringing a burning candle close to the mouth of the test tubes. Caution, this step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? Activity 1.8. Take about 2 grams silver chloride in a china dish. What is its color? Place this china dish in sunlight for some time as seen in figure 1.7. Observe the color of the silver chloride after some time. You will observe that white silver chloride turns gray in sunlight. This is due to the decomposition of the silver chloride into silver and chlorine by light. So silver chloride is AgCl. 2 molecules of it are being taken in the solid form. When it is exposed to sunlight, will be getting converted to silver, which is Ag. 2 molecules in solid form. Chlorine gas. So these are the products and this is the reactant. To balance the equation, the number 2 is used here and number 2 is used here. Flipping to the next page. I hope it is clear. Silver bromide also behaves in the same way. So 2AgBr in solid form in the presence of sunlight will yield 2Ag solid plus Br2 gaseous. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactants in which energy is absorbed are known as endothermic reactions. Carry out the following activity. Take about 2 grams of barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? So in text questions now. A solution of a substance X is used for whitewashing. 1. Name the substance X and write its formula. 2. Write the reaction of the substance X named in part 1 above with water. Question number 2. Why is the amount of gas collected in one of the test tubes in activity 1.7 double of the amount collected in the other? Name this gas. 1.2.3 Displacement reaction. Activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. The 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in a test tube B for about 20 minutes as seen in figure 1.8a. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B as shown in figure 1.8b. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside as seen in figure 1.8b. Next page, please. Let me adjust the window. I hope it is clear and the text is seen. So in 1.8b, iron nails and the copper sulfate solutions compared before and after the experiments are being shown. Why does the iron nail becomes brownish in color and the blue color of the copper sulfate solution fades? The following chemical reaction takes place in this activity. So Fe, which is in the solid form, copper sulfate in the aqueous form will be getting converted to iron sulfate or FeSO4 in the aqueous form plus copper or Cu in the solid form. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reactions are Zn in solid form plus copper sulfate in aqueous form or CuSO4 will give you ZnSO4 in aqueous form plus Cu or copper in the solid form. Pb means lead in the solid form will unite with the copper chloride CuCl2 in the aqueous form will form PbCl2 in aqueous form means lead chloride plus copper in the solid form. Lead and zinc are more reactive elements than copper. They displace copper from its compounds. 1.2.4 double displacement reaction activity 1.10. Take about 3 ml of sodium sulfate solution in a test tube. In other test tube, take about 3 ml of barium chloride solution. Mix the two solutions, figure 1.9. What do you observe? Tech Islamic features. Hi, welcome to my channel. You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. For example, Na2SO4 plus BaCl2 means sodium sulfate when combined with barium chloride both in aqueous form will be yielding barium sulfate BaSO4 solid form and 2NaCl in the aqueous form which is sodium chloride. Next page please. What causes this? The white precipitate of BaSO4 is formed by the reaction of sulfate and barium ions. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Recall activity 1.2, where you have mixed the solutions of lead nitrate and potassium iodide. What was the color of the precipitate formed? Can you name the compound precipitated? Write the balanced chemical equation for this reaction. Is this also a double displacement reaction? 1.2.5 Oxidation and reduction. I hope the screen is clear. Let's read. Activity 1.11. Heat a china dish containing about 1 gram of copper powder as shown in figure 1.10. What do you observe? The surface of copper powder becomes coated with black copper oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. So it will be written as 2Cu plus O2 in the presence of heat will be yielding 2 molecules of copper oxide. If hydrogen gas is passed over this heated material CuO, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. So CuO plus hydrogen gas when heated, it will be forming copper and molecule of water. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction 1.29 means they are talking about this one. The copper oxide is losing oxygen, and in other words, one reactant gets oxide while the other gets reduced during a reaction. Such reactions are called oxidation reduction reactions or redox reactions. So in the reaction CuO plus H2O, in the presence of heat, you will be getting Cu and H2O. Here CuO is getting converted to copper, so that means it is reduced. But H2 is converting into water, so that means it is oxidized. Akshita Jain, hi, welcome to my channel Online Biology Tutorials. Thank you, viewers, for being connecting with me in today's live. In case you are looking for the video series of life processes and the heredity chapter, I have recorded the complete chapter and you can find it in the playlist part of my channel. In reaction 1.31, carbon is oxidized to CO and ZNO is reduced to Zn. In reaction 1.32, HCl is oxidized to chlorine, whereas MnO2 is reduced to MnCl2. From the above examples, we can say that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. So recall activity 1.1, where a magnesium ribbon burns with a dazzling flame in air or oxygen and changes into a white substance. Magnesium oxide is magnesium being oxidized or reduced in this reaction. 1.3, have you observed the effects of oxidation reactions in everyday life? 1.3.1, corrosion. You have observed that iron articles are shiny when new, but get coated with a reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper and silver? When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Hi Premraj, welcome to my channel. I will be recording an explanatory video on this chapter soon. This is the audiobook, right? So once I'll be done, we'll be shortly recording the video on this. Yes, Premraj, I'm just reading because this is the series that I have started today only for recording the audio of all the chapters of 10th, as I was getting requests from the previous subscribers. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all the objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace the damaged iron. You will learn more about corrosion in Chapter 3. 1.3.2, rancidity. Have you ever tasted or smelled the fat or oil containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation or antioxidants are added to the foods containing fats and oils. Keeping food in airtight containers helps to slow down the oxidation. Do you know that chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized? Questions. Question number one, why does the color of copper sulfate solution change when an iron nail is dipped in it? Give an example of a double displacement reaction other than the one given in the activity 1.10. Identify the substances that are oxidized and the substances that are reduced in the following reactions. So one is 4NaS plus O2G will be giving 2Na2O in the solid form. Second, CuO in solid form plus H2 in gaseous form is going to produce copper, Cu in the solid form and H2O in the liquid form. So let's begin with a summary of this chapter 1 of grade 10 Science NCERT. A complete chemical equation represents the reactants, products, and their physical state symbolically. A chemical equation is balanced so that the number of atoms of each type involved in a chemical reaction are the same on the reactant and the product sides of the equation. Equations must always be balanced. In a combination reaction, two or more substances combine to form a new single substance. Decomposition reactions are opposite to combination reactions. In a decomposition reaction, a single substance decomposes to give two or more substances. Ankit Gupta, welcome to my channel. Reaction in which heat is given out along with the products are called exothermic reactions. Reactions in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a displacement reaction occurs. Two different atoms or groups of atoms, which are ions, are exchanged in double displacement reactions. Precipitation reactions produce insoluble salts. Reactions also involve the gain or lose of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. So, with this, we are done with the reading of chapter 1. Class 10 Science NCERT, and the name of the chapter was Chemical Reactions and Equations. In case you have liked the audio, the pronunciation that was done during the live, please do hit the like button before leaving and just visit the playlist. Might be some playlist will help you for learning new things. Stay connected. See you in next video. Thank you.